viewers, welcome to Taxonomy Online Mathematics. In this episode, we want to derive the formula for quadratic formula. We know a quadratic formula is derived from the quadratic equation through the completing the squares. That's one of the methods used in finding a root or a solution of a quadratic equation. We are aware that a quadratic equation is in this form, where the a, which is the coefficient of x squared, the b and the c are all what? Constant. It could be any number except that the a cannot be equal to what? 0. Meaning in every quadratic equation there should be the x squared term. This term and this term can be missing, but still we call it a quadratic equation. Now, in deriving this through a completing square, the first step to do is that to make the coefficient of x squared to be unit, meaning 1. So, the a here, if it is 1, if we divide everything, it is still going to be the same figure we have there. So, imagine if this is 4, this is 1. 4 divided by 1 will still be 4. So, regardless of the number of a, we divide through by a in order to make the first coefficient here to be 1. So that means if I divide by a, I'll be left with x squared plus b over ax plus c over a equals 0 over a will still give us what? 0. So that's the first step. Make the coefficient of x squared to be 1. That's the first thing. Second thing is that we are now moving to the coefficient of x. We deal with the coefficient of x squared. We are moving to coefficient of what? X. In this case, we are taking that coefficient and find half of it. Then we square the half of that. Meaning I am taking b over a. Find half of that. Meaning multiply this by what? Half. And this will be numerators multiplied together to give it b. Then our denominators will be what? 2a. After you find half of that, square your result. Then when you square the result, add that result to both the left side and the right hand side. But before we do that also, we can also transfer the constant term to the other side, meaning subtracting this from both sides. That gives us x squared plus b over ax equals to minus c over a. So after we transfer this, then we add the square of half of the coefficient of what? X. Meaning x squared plus b over ax plus b over 2a all squared equals to minus c over a plus b over 2a all squared. So we add that term to both sides of the equal sign. Now, when we get to this stage, we also know what they call a quadratic trinomial or a perfect square trinomial. Meaning if I have x squared, x and a constant, if the constant is a perfect square, meaning if it is 9, if it is 4, we can break this to become 3 squared and 2 squared. The moment this number is a perfect square like this, we ignore the square. As you can see, we are going to ignore the square and find out if the middle term, the coefficient here, is twice of this. Meaning, if 2 times this give us b over a, if 2 times 3 give us b over a, then we are going to call that a quadratic trinomial, which is a perfect quadratic trinomial. You can see that if I multiply this by 2, I still get this, because the 2 is going to multiply only the numerator. Then they will cancel. I'll be left with b over a. So the moment that becomes true, then it's going to mean that we are picking the first term, which is x, and the term under it, which is b over 2a. Then we put the square on both. We ignore this square, ignore this square, ignore the middle term, because if I expand this term, I will get back the top. So this will now become negative c over a plus b squared 2 squared a squared over this. So now we have the left and the right. The right is with two terms, so we can try to put them together, knowing very well that the LCM will be 4a squared. This can go into that, and that can also go into itself. So if that is the case, if I put 4a squared, a will go there, 4a, as in the a will cancel the square, making this, because there are two of the a, one will go left with 1. This 4a squared going into itself, that will be 1 times, multiplying this to give us what? Plus b, which is going to be square. Don't forget, this is having a negative c, so we add it to it. This a is going here, cancelling the square, so we are left with 4a. The 4a will multiply the numerator, that will give us minus what? 4ac. We can rewrite this with the negative coming after the positive to become b squared first minus 4ac all over what? 4a squared. We are only writing all this to become one term. Therefore, this will be x plus b over 2a all squared equals to b squared minus 4ac over 4a squared. So all attention is on the x. It is the x you are looking for. So seeing this is in the bracket square, we can clear the square, because if I open this bracket, I've come back to these 3 terms. So what will I do? I find the square root of both sides in order to cancel the square, and that will leave us x plus b on 2a equals to, don't forget, since we are dealing with square root in equation, it becomes plus or minus square root of b squared 4ac over 4a squared. And I said, if I have the root of b over c, it could be the square root of b over the square root of what? C. We can separate the square root. So here we can also separate the square root. And if I find the square root of 4a squared, it becomes 4a times a squared. We can separate this. So square root of 4 will be 2. Square root of a squared, it will cancel to give you what? 2a. So if I separate the square root, I'll be having what? 2a as my denominator. So we have x, b, 2a, plus or minus the root of b squared 4ac over what? 2a. You've seen that the root is now affecting only the numerator, not both the numerator and the denominator. But we are looking for x. So now let's subtract b over 2a from both sides. Then your x will not be equals to, we can go and put it there, or put it here, we are subtracting. So I can bring it forward. So minus b over 2a plus or minus the root of b squared 4ac all over what? 2a. Can you see these are two fractions with the same denominators? So if I use 2a as the LCM, 2a into itself will be 1. Multiplying the top will still be the same. So your x will now be equals to minus b plus or minus the root of b squared 4ac, all this sitting on what? 2a. So this becomes the quadratic formula that helps us to find the solution, to find the root, to find the truth set of a quadratic equation. This is the formula. So if I'm looking for x right away from here, I only substitute the value of b, b, a, c, a into this, and I get the values of x. Don't forget, the term under the root, the radicand, is called a discriminant, and it determines, the value of it determines how many solutions we can get to this equation. If the whole of this, you can put the values and get 0. Square root of 0 will still be 0. So you're going to have only one solution, meaning it's going to be minus b over 2a. That's one solution. If the values here is greater than 0, that is positive values, 1, 2, 3, 4, you're going to have two solutions, because minus b plus whatever answer is there over this, minus b minus whatever is there over 2a, that will give you two solutions. And in the case of a negative, then it means you don't have any real solutions. You'll be having a complex solution or complex root. So this is how we solve a quadratic equation through completing the squares. Meaning, if I have 2x squared plus 3x plus 2 equals 0, I'll only take this to be a, take this to be b, take this to be c, and substitute them into where I see a, b, and c. Then your solution is secured if you're using the formula. If you're going to use the method we follow, then you begin to divide through by 2. Find half of the middle term, add it to both sides, find the square root, and voila, there you are. I believe the concept is clear. Like, share, and comment. Share with somebody who may need this on your friend list, and God will bless you. Bye-bye.